Hi everybody and welcome back. Well, I thought I would do a random video today. I know some of you like those, and it gives me a chance to catch up a few things with you. Currently, I am working on the Fisher 800B, and I received my 3D resin printed knobs, and my nephew did these for me, and he did a fantastic job. The only problem was we were unable to get that brown color because there was no true brown, like dark brown resin available, and the color mixes that you can use to color resin didn't give us very good results. So we decided to go with kind of a flat black color, and they turned out really well. I have a brand new set of the brass brights that we'll attach, and we'll see those later in another video. I also ordered in all the replacement capacitors from Hayseed Hamfest. I don't know if any of you have ever heard of them. There's basically two options if you need to buy brand new aluminum can capacitors. One is CE Technologies, which you can get through Antique Electronics Corporation. Plus, I'm sure they're available in other places too, but the one that comes to mind is Antique Electronics, AES, and I think it's www.tubesandmore.com, and they have a whole bunch of different ones, and those are actually made in the traditional manner using authentic, like vintage equipment from the Sprague capacitor company, I believe it was, or Cornell Dubilier, I can't remember, but it's actual equipment that was used back in the day to make those types of capacitors, and they're still making them. The other option is, and this is my first time ever using them, is this company called Hayseed Hamfest, and a lot of you have heard of these guys already, and they even make kits. Like they have a Fisher 800B capacitor kit with all of the ones you need. These are very, very heavy, kind of a mirror polished can, and inside this are regular capacitors. So it's kind of like taking one of these cans and stuffing them with regular, capacitors, and they only use Nichicon and Panasonic and Sprague, high-end caps. They're 105 degree, and everything I'm reading about these guys is really good, so I'm going to try this for the first time. Now this is different from my X101C. When I did that restoration, I used the CE capacitors from Antique Electronics. They worked very well also, but I did notice the big one, right after the rectifier, it had some problems when I first connected it. It actually blew the fuse and a bunch of things, and it got warm because it needed to finish reforming. And I think that capacitor had been sitting on the shelf or something and wasn't properly formed. But once it formed up, it's been working fine. It's perfect, no problem with it. So I thought, well, we'll give this a shot. It sure is going to look nice with the shiny cans and everything. And they are anatomically correct, so all the little shapes correspond to the original factory capacitors from Fisher. So it should be a drop-in replacement. We'll see how it goes. And they even have the insulated ones. If I can find them, here's one. The ones with the paper cover on them, and you can see right there. So more to come on that. We'll see how that goes, but that's what I'm working on right now. We're going to rebuild the power supply and then start tackling the rest of the receiver. If you recall, we had the amplifier section completed, but the power supply had a lot of issues that we have to address. Okay, that's that. Next subject. I have received a plethora of information concerning the Big of California, or BOC, GD108 Stereo 50 amplifier by George Gott. Wow, that's a mouthful. Anyway, I have so much information now, it's almost overwhelming. So many of you helped so much, and there's a couple of you that really got interested in this, and you started researching it yourselves, and you found way more information than myself, and really helped me out. So I appreciate this. Again, I'm a hobbyist, so I don't know everything, And some of this old vintage stuff I've not worked with a whole lot. If some things I have, some things I haven't. This is one that I've not. And this, as you saw from my last video on this, turns out that this was a very popular design back from 1959 to maybe about 1961 or so, 62. And Big of California just kind of threw their hat in the ring, and they had their model that was out there, and that was this GD108. Although this is the only one I've ever seen or heard of, and I know that I had a couple of comments that they were pretty popular in California, and that possibly these were released and they were in production and so forth, but I don't know. I haven't been able to find any information online. Now, a couple things about the design that we were questioning in the last video. You'll have to go back and refer to that video to understand what I'm talking about. I made a comment that this particular part of the schematic, which is the input, so you have your right and left input, and you have this 12AX7, and I know it says 12AU7, don't pay attention to that. And like I said, the cathodes were tied directly to ground. And I said, well, you probably would need a cathode bias resistor. But it was brought to my attention to actually look at what we were doing here. There is a 3.3 meg, not a 33K or a 100K or a 68K or whatever you're used to seeing, but a 3.3 meg grid resistor, okay, grid leak as they want to call it. And we have a capacitor coupling on the input, and we have a 100K anode resistor. This type of circuit it can be referred to as a couple different things. You can either call it point mode or contact mode, and another maybe more informal way to call it is starvation mode. So this is actually a valid circuit design, and it will actually work because of the ultra high impedance here. So this actually is factory. I believe this is the way it was supposed to be. Now, no one could seem to explain why there were two 0.02 microfarad capacitors in series like that to ground, going from one leg of the input potentiometer, your level control. And the only thing I could think of is that kind of filters off frequencies at about 150 hertz, 160 hertz, something like that. And of course, back in this era, that was most likely all that anybody was concerned about. Now, there was a few different comments that I got. Some people were saying that probably this was designed to only work with phonograph. And so my concerns about things, were unfounded. But then again, the owner who acquired this said that it came out of a console system, and there was an accompanying preamp with it, and I forget the name of it on the top of I think it's called a Sonostat preamp by BOC, and I'll put the name up there I'll put a little note here. And it was in the console next to this amplifier, making you think that, well, those two things were together. Now, some other people made some comments that this filter in here could perhaps be a very rudimentary type of equalization or de-emphasis for the record. Maybe, I don't know. But this is definitely pretty interesting. The other thing we were talking about is when we were switching between stereo and mono mode, and if you recall from the video, I redrew this schematic and I eliminated everything related to the switching between mono and stereo. And I showed you a few other schematics of other designs that were out there from like Popular Electronics magazine and things like that showed some ideas of how to switch between stereo and mono mode. And one of them involved, shorting out this common mode transformer, which would have not been a very good idea. But anyway, I believe the clue in how we did this on this particular amp was that convergence potentiometer, which I believe is a 1K pot or something like that, that was not connected to anything. It had been removed from the circuit by somebody that was trying to service this. And I believe now that pot was probably wired somewhere between the output of the output transformer, possibly, I'm not sure, and between these two inputs. The other thought I had is that that potentiometer was wired between the anode side of one of these tubes and the grid, input grid of the other tube, to make a type of an inverter, okay? And that would be called a paraphase inverter. So they use that pot to adjust the balance between the phase inverter and set up like a paraphase inverter with that. And that could be done probably with some DP-DT switch, for instance, switching that potentiometer in and out. And then what would happen is you would have the one input here for your mono, and then it would pick off the anode, which is inverted, right? And then it would bring it back into here, which would invert it once again, so they would be 180 degrees out of phase. So that could be one way that we could do that. So I'm not sure. Like I said, there's probably a couple different ways you could wire that pot in there to do that, but my guess is that's what they were doing with that. So just a few things. I had another person ask me about this design, which is out of this one magazine, where I said that you had two identical output transformers, and both of them are push-pull type. And someone said, well, if you only use the one lead and ignore this one, well, then that makes it a single-ended transformer. And you'll have to go back to my video to explain it, to see why I had a problem with that. I just wanted to clarify something, that there is a difference between a push-pull transformer and a single-ended transformer beyond just having that extra winding on it, okay? And what it mainly is this thing is kind of, when it's set up for idle, it's electrically neutral, meaning that you have equal and opposite current flowing in both directions, one going from here to here and the other going from here to here. And because you have that, it's electrically neutral here with respect to the core, so this core is not magnetized in any way when it's sitting at idle, as long as both tubes are matched. Now with this one down here, you only have current flowing in one direction through that coil. Because of that, that will set up a magnetic field, and you'll get what's called core saturation, meaning that that iron core of this transformer will be magnetized, and it's saturated, meaning when you go to drive a signal through it and make a changing magnetic field, that strong magnetic field would have to demagnetize. It would cause incredible amounts of distortion, and it wouldn't work. The way they get around that on a single-ended transformer is they put an air gap in the core. So the actual core is designed differently than a regular push-pull transformer. And some people don't know that. I mean, I actually went through it myself where I forgot about that, and I tried to do that. It didn't work. I actually tried to use a push-pull transformer for a single-ended design, and it didn't work. And just like I said, it was very distorted. And the other thing you can get is called core memory, where that iron core can become permanently magnetized, so that even when you use this in, like in its intended purpose, you'll get distortion because it's magnetized in one direction. So there will always be more current in one direction than in the other, and that causes all kinds of problems. So anyway, I just wanted to clear that all up. Another thing I wanted to address is I've had a few comments on not having an email address or not being able to communicate with me beyond the comments section. I did that on purpose, and I did a video on that. The only people that can directly contact me now are my patrons on Patreon. I didn't do that because I want to make money, okay? I don't care about the money on that. And you can believe it or not believe it. It doesn't matter to me, But I own a business. I don't need the money. I do this as a hobby. You can tell by the janky videos you get from this site. Nothing's professionally edited or set up or anything. You hear all the family in the background and everything. But honestly, I did that because two reasons. Number one, when you put your email out there, if you're a YouTube creator, you're going to be opened up to a lot of spam. I was getting a lot of, well, advertisement things, which are a pain, but then you get a lot of things where people would send you a PayPal request, for instance, or they would send you some note that makes it look like, you know, from a government agency, and it's all fake, you know that. But you got to sift through all that garbage. You just get so much spam that it became a chore, and I got so many questions that I just couldn't answer. You know, it just got more than I could handle. So I thought, what is the most fair way I could do this and still be at least somewhat accessible to people who are doing this and want to learn something, that are working on something. So I decided to go this route with the Patreon thing, and I can tell you it has worked out really, really well. I've been able to spend a little more time with people who are seriously working on a project or something and have some questions than I had before. So it's been great. I'm sad that I can't reach out to every single one of you, because it's not that I want you to pay to email me, but I have to do something to put a buffer zone between YouTube and my email or whatever, you know, or the Patreon comments or whatever. And Patreon kind of acts as that buffer zone. That's the only reason I do it. And again, some of you are going to be mad, some of you aren't, some of you will understand, some of you will not. I understand that, I get it, but it's the way it's going to have to be for me. I appreciate those of you who choose to be Patreons or patrons, and I try my hardest to help you out. I do have for instance, I have a Dropbox up there, or a drive, you know, a live drive that I drop a lot of my schematics and things on, that we can share information, and the patrons have the ability to download those things and stuff like that. So I try to do something nice for that, but honestly, that's the main reason I'm doing this. Anyway, that's it for now. And one last thing. Now, the last thing I want to do in this video, other than make the camera shake around, is to thank all of you for your participation in this last couple of videos I did. I think we've learned a lot together about this whole thing, about these these stereo mono amplifiers, and it was the simplex stereo, as they call it. I was very fascinated by it, and I do intend to build a mock-up of one of these and to see it work. And with all this information I've acquired, I have been sharing it with Greg, who is the owner of this amp and who's the one that's working on restoring it. And he's very slowly and meticulously going through it, and when he gets it to a working point, we're going to get some video of that, or at least some photographs and some information, and we're going to talk about it. And maybe when I get a chance to tinker around at the bench, I'm going to I do have a single-ended amp that's got kind of a good-sized chassis on it that was just a project amp that's sitting in my warehouse. I'm going to use that, and I'm going to try to reform that into one of these simplex amplifiers so we can see how it worked. And we may even try to change the front end a little bit so that we don't have to use an out-of-phase cartridge. We'll try to do something like this Big of California amplifier if we can, to make kind of a switchable between stereo and mono type thing. We'll find out. We'll play that one by ear. But anyway, I wanted to thank you all for all of the hard work you did and for sending all the information. And I wanted to just say thanks, and that I will keep you posted so that we can see this project all the way through to its completion. As always, I wish you all peace, joy, happiness, and good health in your lives. Hope to see you again real soon here on this Fisher amplifier and receiver, and we'll be back real soon. Take care.